Hi guys, this is Leo Chen. Today we're going to learn how to solve a system's equation with three variables. Let's first look at the system equation with three variables only. Alright, so this is an example we're going to look at, which we are going to try to solve it today. In order to solve a system equation with three variables, we need to learn how to solve the equation with two variables only at first. Then we need to be familiar with the method substitution, elimination. Alright, let's look at this equation. Usually in the system equation with three variables, the x, y, z are common variables. It represents a three-dimensional space, like this. Each equation represents a plane. For example, the first equation might be represents a red plane, and each other two represents a unique plane right here. So to solve a system equation, we need to find a solution that works for all three equations. So it is a point where all three planes intersect going to be the unique solution that will work for all three equations right here. Steps for solving a system equation with three variables. Alright, first pair up equation to eliminate one variable first. So let's look at our original equation right here. X minus 3y plus 3z equal negative 4. 2x plus 3y minus z equal 15. And here's x. 4x minus 3y minus z equal 19. So we can all see minus 3y plus 3y minus 3y. It looks like a good problem to do elimination on it. So in this case, I will do elimination. And I'm going to eliminate y first. So we set up our elimination process. Like x minus 3y plus 3z equal negative 4 on top right here. Then we put this equation on the bottom. Or I can do it either way. I just like my personal preference. So x plus 2x equal 3x. Negative 3y plus 3y equal nothing right here. So positive 3z minus z equal 2z. Now equal sign right here. Then negative 4 plus 15 equal 11. So we're done with the first one. Now I set up another one. 2x plus 3y minus z equal 15. Then like 4x minus 3y minus z equal 19. So 2x plus 4x equals 6x. 3y plus negative 3y equal nothing right here. Negative z minus z equal negative 2z. And equal sign right here. 15 plus 19 will just equal 34. After the process of elimination, you'll get two new equations, which is right here. Now, we will apply our old way of how to solve a system equation with two variables only. In this case, I will use the method of elimination again to find out one variable for this equation. So we set up our two new equations in the elimination process. I'll put 3x on top, so like 3x plus 2z equal 11 right here. Then another equation just on the bottom. So 3x plus 6x equal 9x. 2z plus negative 2z will just nothing right here. And equal sign. 11 plus 34 equal 45. Now we divide by 9 on both sides. X equal 5. Yeah! This is a solution for one variable. Now let's do more substitution. After we solve for one variable, we'll substitute it into our old equation, which is a new equation, which is two equations we just created. So that is two new equations we come up with on the previous slide. Alright, now let's plug it in. I will use 3x right here. So 3 times x, which is equal 5, what we found on the last slide. 3 times 5 plus 2z equal 11, which will equal to 15, plus 2z equal 11, minus 15 on both sides. 11 minus 15 equal negative 4 right here. So 2z equal negative 4 divided by 2 on both sides. Z will equal to negative 2. Now we found out z equal to negative 2. Let us substitute back into another equation to double check our answer first. So we substitute in this equation. 6 times 5 minus 2 times negative 2, which is z, equals 34. 30 minus negative 4 equals 34, which equals to 30 plus 4, because minus negative number is like plus a positive number right here. So 34 will equal to 34. Yeah, we did it correctly. Finally, we can substitute these two variables into our original equation. So we can get our last variable. That is our original equations in the first slide. I substitute in, I choose this equation to substitute. 4x minus 3y minus z, so 4x equal 5, right? So 4 times 5 minus 3y, we don't know y yet, minus z, which is negative 2 right here, equal 19. So 4 times 5 equal 20, minus 3y, now minus a negative 2 equal plus 2 again, so equal 19. So let's simplify it down. So we'll subtract 20 and 2 on both sides. So this side we only have negative 3y right here. And this side is like 19 minus 20 minus 2, which is 19 minus 22. 19 minus 22 equal negative 3. And negative 3y equal negative 3. We divide negative 3 on both sides. So y equals to 1. Yeah, we found out our y now. Final check our answer right here. Congratulations, we figured out the variable. According to previous calculation, we found out x equal 5, y equal 1, and z equal negative 2. To put it into correct notation, our final solution is 5, 1, negative 2, and second parentheses. Now we will substitute this solution back into our original equations to check if our answer is correct. So here again is our original equations. The first one, x minus 3y plus 3z1. Okay. So x equal to 5, so 5 here, 5 minus 3, 1, so it's 1 right here, plus 3, 3 times z, which is negative 2 we found out, equal negative 4. So it'll be 5 minus 3 plus negative 6 over here, equal negative 4. 5 minus 3 equal 2, and 2 minus 6 is negative 4. Negative 4 equal negative 4. Yeah, our solution worked for this first equation. Let's check our second equation right here. 2x plus 3y minus z equal 15. Okay, so x equal 5. 2 times 5 plus 3, 1, which is y right here. So minus negative 2, which is z equal 15. Which 2 times 5 equal 10 right here. 3 times 1 equal 3, and minus negative 2, I will just still minus negative 2 right here, equal 15. 10 plus 3 equal 13 right here. Sorry, and minus negative 2 will be like plus 2 now. So 10 plus 3 plus 2, which will be 15, and 15 equal 15. Yeah! For our second equation as well. The last one. Okay, 4x minus 3y minus z equal 19. So 4 times 5, which is x, minus 3 times 1, which is y, minus negative 2 against z equal 19. We 20 minus 3 right here, and minus negative 2 will be equal to plus 2 equal 19. So 20 minus 3 equals 17. 17 plus 2 equals 19, and 19 equals 19. Yeah, our solution worked for all three equations. Congratulations, we successfully solved one system equation with 3 variables. Alright, that's the end of the video. Thanks for watching, guys.